everyone, in this video we're going to go over right triangle trig, which is something that you already know a lot about from geometry. So in this video there's going to be a lot of review from what you learned in geometry, and then there'll be a couple of new things that aren't so difficult once you remember some of the things from geometry that you learned. Okay, so the first and most important thing that you remember from geometry is the Pythagorean theorem. The Pythagorean theorem could be used with any right triangle, and we know a triangle is a right triangle if it has a right angle. So I'm going to sketch a right triangle here. Okay, and you know my sketches aren't going to be perfect, but let's say this is the right angle. Right there. A right angle, remember, is 90 degrees. And the sides of this right triangle are important. So opposite the right angle is always the hypotenuse. And then the two sides that form the right angle are called the legs. And the legs for the Pythagorean theorem are interchangeable. The Pythagorean theorem says that the hypotenuse squared equals the leg, one of the legs squared, plus the other leg squared. And the way that we usually denote this is by the legs being A, B, and the hypotenuse being C. So this is probably the traditional way you've seen it, is that C squared equals A squared plus B squared. And this is really helpful if we need to find one of the sides of a right triangle. So let me just do a quick example of what I'm talking about in the next slide. So here's an example of how you would use the Pythagorean theorem. Let's say we had a right triangle, and let's say that this side was 6 and this side was 10. I'm just making these numbers up. Now the goal of this example is to find this missing side. We'll call it x. So the example is to find the length of side x. Okay, so I'm going to apply the Pythagorean theorem, and I know I'm allowed to do that because this is a right triangle. So you could use the Pythagorean theorem with any right triangle. I'm going to label my sides so I know what they are. Here's the right angle. Opposite the right angle is the hypotenuse. I know this is a leg and this is a leg because those are the two sides that make the right angle. So now I'm going to use my theorem. A squared plus B squared equals C squared, and because of the equality I know I could switch the order there. Right before I had C squared equals, now I have A squared plus B squared equals, the same thing. And now I'm going to substitute in the sides that I can substitute in. So I'm going to put A as x, they're variables, so I could just interchange that. And then I'm going to put B as 6 because that's one of the legs. And then C is going to be 10 because that has to be the hypotenuse. Okay, and now I'm just going to work a little math magic here and solve for x. So I'm going to have x squared plus 36 equals 100. And then I'm still isolating x squared, so I'm going to subtract 36 from both sides. And I get x squared equals 64. And now to get x alone, I'm going to square root. Remember when you square root that it's plus or minus the square root, but in this case we're just going to take the plus because we know that this is a triangle and that the sides in this particular triangle, because it's not on the coordinate plane, is going to be positive. So I just found that the leg here, or the length of side x here, is 8. I didn't put any units, so I'll just put 8 units. But if it was like centimeters or inches or meters or whatever, you would write the unit of measure as well. Okay, and that's what you need to know for Pythagorean theorem. Next, we're going to go over some of the trig ratios. Okay, so I'm going to draw another right triangle, because remember, we're only doing right triangle trig right now. And I'm going to draw it this way because I keep drawing it the other way and I don't want to draw them all the same way. So here's my right triangle, and just erase that because I went over. All right, so there's my right triangle. Here's my right angle, right there. And remember that opposite the right angle is always the hypotenuse. Okay, now in geometry you learned about 3 of the 6 trig ratios. Okay, those 3 that you learned about were sine, cosine, and tangent. These are how you spell them out, but usually when we write sine of something, it's going to be sin. When you have cosine of something, it's just going to be cos, and then when you have tangent of something, you just have tan. Okay, but what we're going to be doing is finding these values of certain angles. So now I'm going to go back to my triangle and I'm going to label them. Let's call this A, B, C. So now I have triangle ABC. So this is angle A here. This is angle C here. And B has the right angle. Okay. And something else you learned in geometry, that opposite the angle, the sides are the same. So opposite angle A is side A, opposite angle C is side C, opposite angle B is side B. So in this case, the hypotenuse is side B. Okay, so now if I want to find the sine of A, sine is always defined as the opposite over the hypotenuse. So now I'm going to look at A. So A is here. I just put a circle around it. Okay, and I'm going to determine which side is the opposite of A. And I kind of already said this before. The opposite of A here, I called it A, but that's the opposite. Okay, so now I don't have a value for that right now. I'm just going to call it A. Okay, the hypotenuse is just the hypotenuse of the triangle. So that's going to be side B. So A over B, whatever those values would have been. And we'll do an example next. Cosine is adjacent over hypotenuse. So if I want to find cosine of A, and the angle is important, right? Because I could also be asking about C, but I'm specifically asking for A in this case. A is going to be over here again, so I'm looking at this angle here. And the adjacent side is the side next to. Adjacent means next to. So that's going to be this side, side C. So this is going to be C over B, whatever those values are again. Tangent is opposite over adjacent. So if I want the tangent of A, look back at A, I want the opposite, so that's going to be A, over the adjacent, which is C. So those are the 3 trig functions that you should already know from geometry. And probably in geometry you learned it as Sohcahtoa. A lot of people use this to be able to remember which ratio goes with which trig function. So like for instance, so S sine, O opposite, H hypotenuse. Okay, but it is really important that you denote which angle you're talking about, because that's why I kept saying like angle A here, because if I asked you for angle B, the opposite and the adjacent sides would be different for angle B. Okay, so I'm going to do a quick example of how you would use a triangle and find these 3 trig ratios, and then I'm going to introduce the other 3 that you didn't learn in geometry that you learned in pre-calc. Okay, so I'm going to draw another right triangle. I know it's a lot of right triangles that I'm drawing. And I'll just draw it the way that we're used to. Okay, so that's going to be theta. That's going to be the right angle there. And then I am going to have theta here. Okay. And then opposite theta is going to be the square root of 7. Adjacent to theta is going to be 3. And the hypotenuse here is going to be 4. Okay. Now what I want to do here is I want to find the sine of theta. I want to find the cosine of theta. And I want to find the tangent of theta. So remember, sine is going to be opposite over hypotenuse. Theta is here, so the opposite is going to be square root 7. So I'm going to have square root 7, right? That's the opposite of theta over the hypotenuse, which is 4. And this is fully simplified, so that's my final answer. Okay, cosine is going to be adjacent over hypotenuse, so the adjacent angle here would be the 3, right? That's the side that makes up theta. So it's going to be 3 over the hypotenuse, which is 4. And 3/4 is fully simplified, so that's done. Now tangent of theta is going to be opposite over adjacent. So the opposite again here is square root 7, and the adjacent is 3. Okay, and that's all we need to do for this example. We just found the sine, the cosine, and the tangent of the theta. Okay, now we're going to look at what we call the reciprocal functions. The three other trig ratios. Three trig functions has these ratios are the reciprocals, another of the three that you already know. So it's not going to be that much different. We're going to look at how they are related to the three that you know. And once you really know those first three, it's pretty easy to get the other three. So we know sine is opposite over hypotenuse. We know cosine is adjacent over hypotenuse. And we know tangent is opposite over adjacent. Okay, so now what we're going over are called the reciprocal functions. And you should know reciprocals from other math classes that you've taken. A reciprocal is when you have the multiplicative inverse, so it's like 1 over whatever number that you have would be the reciprocal. So like the reciprocal of 4 is 1 over 4. So 4 and 1/4 are reciprocals. If you have a fraction like 3/5, the reciprocal of 3/5 is 5 over 3, because if you actually did 1 over 3/5, you would get 5 over 3. So the reciprocal functions are going to be the reciprocals of sine, cosine, and tangent. So the first one is cosecant, so I'm going to write out the whole word first. And the way that we abbreviate this is CSC, that's cosecant. And cosecant is the reciprocal of sine, so that's going to be 1 over sine. And I'm just going to show you really quick what this simplifies to. So 1 over sine means that we have 1 over opposite over hypotenuse, right? Because sine is opposite over hypotenuse. And now when we divide by a fraction, that's really multiplying by the reciprocal. So I'm just going to come down here. And we have 1, it's 1 divided by opposite over hypotenuse. So that's 1 times hypotenuse over opposite, which is just hypotenuse over opposite. So that means, and I'm going to write it here now, cosecant equals hypotenuse over opposite, which is what you would expect, right? If it's reciprocals, you expect for the fraction to flip, right? For the numerator become the denominator, denominator become the numerator. It works the same way for these other ones. I'm just not going to go really through this proof. This was like a side note for me to show you why. But the reciprocal of cosine is secant. So that would be SEC when you abbreviate. And again, that's 1 over cosine, which means that secant equals hypotenuse over adjacent. And then the last one, tangent, the reciprocal is cotangent. And the way that we abbreviate that is COT. Again, it's the reciprocal, so it's 1 over tangent. And you could do all the work and you'll end up getting that cotangent equals adjacent over opposite. Okay, so these are our new trig functions, cosecant, secant, and cotangent, and their definitions. And in the next slide, we're going to do an example where we have a triangle and we have to give the exact values of all 6 of the trig functions now. Okay, so this example is to find the exact values of the 6 trig ratios of theta. So I'm going to draw my right triangle. This is the right angle here, and theta is over here. This side is 3 and this side is 2. Okay, so I know that I want the 6 trig ratios. So that means what I'm looking for is sine of theta, cosine of theta, tangent of theta. And remember, the other 3 now are the cosecant of theta, the secant of theta, and cotangent of theta. Okay, in order for me to find this, I need to know what all the sides are. And remember, the first thing that we went over today was how to find a missing side of a right triangle. So in this case, what I'm missing is the hypotenuse. Right, it's opposite the right angle, so I'm going to apply the Pythagorean theorem to figure out what this is. So, Pythagorean theorem over here, a squared plus b squared equals c squared. So I'm going to have 2 squared plus 3 squared equals c squared. So that's going to be 4 plus 9 equals c squared. That's going to be 13 equals c squared. So square root of 13 equals c. Okay, so now we know sine is opposite over hypotenuse. So that's going to be, let's see, theta's here. So if that's theta, this has to be the opposite and this has to be the adjacent. So opposite is 2, so it's going to be 2 over root 13. And we wouldn't leave our answer like that because that's not rationalized. So I'm going to multiply by root 13 over root 13 to simplify. So now I'm going to get 2 root 13 over 13, and that can't be simplified anymore, so I'm done. And now I'm going to go to the cosecant because I just did the sine, and I know cosecant is the reciprocal, so that's going to be the hypotenuse over the opposite, so that's root 13 over 2. And that one's done. Okay, next one, cosine. Cosine's adjacent over hypotenuse, so adjacent is 3, so it's going to be 3 over root 13. Again, I can't leave my answer like that, so I'm going to multiply by root 13 over root 13, and that's going to be 3 root 13 over 13. Okay, secant is its reciprocal, so I'm going to do hypotenuse over adjacent. The hypotenuse is square root 13, the adjacent is 3. That one doesn't need to be simplified anymore, it's done. So that's my answer there. Tangent is opposite over adjacent, so this is going to be 2 over 3. And the cotangent, let's do that. The cotangent is going to be the adjacent over the opposite since it's the reciprocal of tangent, so that's going to be 3 over 2. I didn't mean to not box that cosine equals this, it was just that it went to another line, so that's why I just boxed the first thing. Okay, and that's an example of how you would find the exact values of some triangles, theta. And, you know, sometimes we might have to use Pythagorean theorem with this type of problem. Okay, In the next slide, we're going to go over the special right triangles. Okay, and this is something again that you did in geometry. And I'm going to be posting 2 videos of some basic trig things just in case you don't really remember these from geometry because it's been a long time, where you can go through how we develop the special right triangles and like what they are, and then also some of the right triangle trig ratio stuff, just in case you need a brief review from the geometry courses. So we have 2 special right triangles. We have the 30, 60, 90 triangle, and then we have the 45, 45, 90. So 30, 60, 90 triangle, and then you have the 45, 45, 90. Okay? So I'm going to draw them out, label the sides in general. Again, this is something that you should know from geometry. I believe every single geometry course does it, whether you took it in middle school or high school, doesn't matter. It was something that you probably had to memorize, and you should memorize them again because you will have to reference these many, many times in pre-calc. So if you need to re-memorize them, it's a good idea to do that now in the beginning of the course. Okay, so first I'm going to go over the 30, 60, 90. Again, I'm just going to be labeling the sides. So this is the right angle, that's the 90. Here's the 30, here's the 60. It doesn't matter where I place them. Okay, opposite the 30-degree angle is x. Opposite the 60-degree angle is x root 3. And opposite the right angle, or the hypotenuse, is 2x. Okay, again, these are the sides in general. Any special right triangle that's a 30, 60, 90 triangle will have these side lengths. Now, x could be any number. So that could mean that if x is, let's say, 4, I'm just going to draw what would happen if x is 4. Okay, so if x is 4 here, then this side is 4 root 3, and this side is 8. Okay, so all the x's become 4, so that indicates that these are the new sides. Okay, so you should memorize it in general because these sides always apply. Okay, now the 45, 45, 90. This is an isosceles triangle, so it's a bit easier because we know the 2 sides that are opposite the 45-degree angle are going to be the same or congruent. So the way that I do this one is that the ones opposite the 45s are x's, and then the one opposite the right angle, the hypotenuse, is x root 2. People do this one a little bit differently, but I think that this is the most popular way. And that's the one that we generally use in pre-calc. Again, the x could be anything. Okay, and now I'm gonna show you an example of how we would use the special right triangle. Okay, so let's say I asked you the cosine of 60 degrees. Now we want to be able to find the trig values of any of the special angles from the special right triangles from our memory or from the right triangles instead of using a calculator. We want to know these values instantly, and we'll get there. In the beginning it's a little harder, but we're going to get to the point that you know these instantly without using a calculator, because the calculator won't give you the exact value for some of them, so that's why we don't want to use a calculator. And the reason why we want to know these so well is because you're going to use 30, 60, 45 over and over and over again in pre-calc. So it's really important to get it down now, because once you get it down, it's going to save you a whole bunch of heartache later, I should say. So the way that I would find cosine of 60 degrees is I would make the right triangle. I know 60 degrees is in the 30, 60, 90, so I'm going to recreate that triangle. Remember before I told you that you should memorize the triangle and be able to reference it whenever, so that's why I'm drawing it. So this is x root 3, and this is 2x. Okay? Cosine of 60 is going to be adjacent over hypotenuse. So adjacent is x, hypotenuse is 2x. So x over 2x is 1/2. So the cosine of 60 is 1/2, and I'm done. Notice I did not type anything into a calculator, I just used my triangle. Let's do one more. So here's another example. Let's say I wanted to find the tangent of 45 degrees. So what I'm going to do here is now I'm going to create the 45, 45, 90 triangle. So here's my 45s. So this is x root 2. And I'm trying to find tangent of 45. So I know tangent is opposite over adjacent. So here's one of the 45 degree angles. The opposite is x, adjacent is also x, so x over x is just 1. So the tangent of 45 degrees equals 1. Notice again, no calculator, just used my triangle. And I could do this with any of the trig ratios, so I could find like secant of 30 degrees or something like that. I could find the sine of 45 degrees. So any of the 6 trig ratios and any of the angles 30, 60, 45, we could ask you to do, and you would just recreate the triangle. You can also be asked to find or label the angles or one of the sides if it's a special right triangle. So let's say I had this triangle. I know it's a right triangle, and the sides that I have are 12, 6, and 6 root 3. So if I gave you this triangle and I wanted you to tell me what the angles were, you would use that it's a special right triangle, and based on the sides, 6, 6 root 3, and 12, you know that this is x root 3, and this is 2x, meaning that it's a 30, 60, 90 triangle. So this would be 60 because it's opposite the x root 3. This would be 30 because it's opposite the x. So this is just another example of something that could come up. You might have to find the angle, or if one of these sides were missing, like let's say the 12 wasn't there and you had to come up with the 12, that might be another thing you might have to do with a special right triangle, but these should be things that you did in geometry. And that's pretty much everything that you need for right triangle trig. There are a couple other examples that we'll do in the live classes together pertaining to this, and then in our next videos we'll be doing more work with the coordinate plane and how angles are drawn on the coordinate plane, and then also instead of degrees we'll be talking about radians, which is just another way to measure angles. Okay, so that's it for the right triangle trig video.